All right, and we're live. How's it going, everybody? So, I appreciate you all tuning in. Today we're going to be doing something a little bit different. If you've been following along for the past, I don't know, so 8 weeks, I guess the past 4 weeks, we've been working on a feature in the compiler called stable inference. And it's not quite done yet. I'm getting closer, but I feel like the kind of interesting bit of that work has kind of been done on stream, and so I thought it'd be interesting if today we started something new. And so I don't know how many of you are familiar with function interfaces, but let's see. Kotlin 1.4 added these, and the general idea is that you can have, in Kotlin, you have function types. So if I wanted to add like some callback parameter that, took an int and, did something with it, I would describe that in this way. So this is just like a function type in Kotlin. But what I can also do is like, I can create an interface called, int method or whatever that does something, and so in this case it needs like a single method on it, and so that could be, whatever the name of it is. And so I define this like I would a normal interface, and so without this fun in front of the interface declaration, then what that means is if I wanted to do this, that wouldn't, so that works, but it's not really like a direct substitution. So let's just say, let's not deal with composable right now. So let's say I had some function that took this this type. What I can do is if this callback is a lambda type, then I can just pass in a straight up like lambda literal to it. Sorry, I just realized I wasn't looking at our chat. Sorry, I apologize. I just realized I didn't have our chat pulled up. So hi Avian, hi Tutor, how's it going? Hey Retsy. So let me pull that up. Okay, I think I'm good to go. So function interfaces can kind of help us out here. Like maybe what you want is you want to kind of declare this as like a kind of a first class type, but since it's just a single method here for this interface, you kind of want to let people use a lambda syntax to denote it. And so if you were instead to use like int method, then you'd have to do something like this currently. So you might say int method and then override fun, do something, etc., stuff like that. So like this is obviously more verbose, and you know it's kind of semantically equivalent. You're just replacing a lambda with a object literal, and and so this capability is pretty nice. The other thing that's pretty nice about it is that if you had something like this, unfortunately right now what happens is that because in the JVM this turns into like a function one class that has two type parameters, int and unit. So this is basically equivalent to saying function one int unit. And so because then this int is being put into a type parameter, in the representation of this in bytecode is just that it's function one, and these are just two objects because of type erasure. And so because of that, the int will usually get boxed. But if we have an interface with a formal method here, then this will be not boxed in JVM. So there's also some value to having this. And so this fun interface kind of gives us the best of both worlds. And what we're going to do today is we want to make sure that you can represent this where the function interface method is composable. And so that would be equivalent to having like a parameter like this. And I believe that right now our compiler isn't properly handling this case. And so that's what we're going to be investigating. All right. Let's see. So Alex Lockwood asks, by the way, hi Alex, good to see you in here. Alex says, I'm late to the party. Can compose finally use fun interface now? I've noticed 4 or 5 to-dos in the source code indicating that it's blocked on Kotlin 1.4. Not sure how outdated those comments are. So there's a few things here. Right now, there's nothing preventing you, the user, from using function interfaces in general. What might be broken right now is using function interfaces where the method on the interface is composable. However, in our source code, you might see places where we're not using, where there are to-dos saying convert this to function interfaces. Those comments are probably outdated to a degree, but there's also, it's not like we're blocked on potentially other things as well, because we have some tooling that that like tracks APIs and stuff like this that I think does not currently handle function interfaces properly. And so we're trying to figure all that out, but I believe most of it's been handled, and that now we're going to be using it. And I believe there might already be a few function interfaces in compose source. Skycolor asks, will that even be a real use case for the developer? Sorry, Skycolor, can you ask like specifically what you're asking? Like if having a composable function interface is a real use case? If that's what you're asking, then I definitely think yes. The same as it would be a real use case to have a non-composable method. But if you're asking something else, let me know. Yeah, so definitely, I mean, I think just like we have composable lambda types, definitely there's reasons for those to be function interfaces instead. Greg Cargan asks, hey Leland, I saw interface Thunk T in your tweet. What's the idea behind that? Not really like any specific idea. I was just kind of writing some examples, but so we go back here. I mean, so a thunk is really just a, you know, like sort of like a lazily evaluated value. And so you can think of a lambda that returns some type as kind of like a thunk, where to, you know, like any getter, really, any property getter in Kotlin really is sort of like a thunk. But I mean, you might want to ask, like, if the property getter is just returning the result of a field, then it's not really lazily evaluating anything. And I think that thunk sort of canonically is lazily evaluated. And so there's no reason why composable isn't a valid thing here. And so you could have, I mean, you could ask, for instance, to you know, to just have some value that provides or some function that provides some value t, and if you're going to get that value, if you're going to invoke that function in a composable context, then and you know, based on the context, that might make total sense. Then you might also be able to say, okay, since I'm invoking it in a composable context, you can provide it to me in a composable context. And so the at composable would kind of enable that. But that said, I mean, I just used this as an example, so there's not any significant sort of thinking going on here. It was just an example I thought of on the top of my head, so don't read too much into it. So let's see. Vicus asks, is there any way we are optimizing the lambdas right now in Compose, and also how introduction of function interfaces will impact this? Roughly speaking, yes. There's a lot of lambda specific optimizations we do in Compose, and I might elaborate on that later on in the stream, but it's, I guess to answer the second part of your question is how do functional interfaces impact this? That's one of the things that we're gonna figure out, you know, right now. I haven't looked into this in detail. I don't know exactly how function interfaces are implemented in the IR backend, and I need to kind of figure that out so I can figure out how our Compose compiler plugin can like support composable functions on them. Skycolor says, I would really see fun interfaces out in the wild in some Compose app repositories. Are you saying that you rarely see that? If so, that's not really that surprising, considering they haven't been available until Kotlin 1.4, you know, which Compose didn't support until just a few weeks ago. So I don't think that's all that surprising. Yeah, okay, great. Let me know if any of you have any more questions. Good questions so far. So let's dive into this. I think the first thing I want to do is just set up a test of a few different function interfaces that are composable, and sort of see what breaks. So the first thing we might do is, I actually have this, we have these tests called signature tests. And what these do is this, let me know how legible this is, if I need to zoom in any further or anything. So what these tests do, which is kind of interesting, is we write some source code on the one side, and then what happens is that we go all the way to generating bytecode, and then we just assert on the signature of the class files generated. So none of the bodies of any functions, but just the kind of public and private API signatures of everything. Yeah, I'll increase it a bit. So you can see here that, like, doing something like this, where we just have, you know, two composable functions, a lambda, and some stuff like that. This generates quite a bit, and we can like walk through what this is. So this is the file class, and you can see that here, you know, foo and example are these two methods here. And then there's a few inner classes that are generated. And so that's because there's a lambda that is generated for each one of these composable functions, which allows it to restart. And so that's these two things. And then this lambda here also generates a third lambda class. And so that is here, I'm guessing. And so three lambda classes. And some of those have capture scopes, some don't. So this is the first one, and it captures a change parameter and basically the parameters of this function. You know, and then the other lambda class. I'm not going to go into all of them, I guess, that at this point, but that just kind of gives you an idea of how these tests work. So I think what I'm going to do is I'm just going to create a new test. Put it here on the bottom. Find interfaces. We'll just start off with that. And let's first just see what happens when we have just a functional interface, like, so nothing compose specific at this point. And let's just go ahead and give it an int and a return type, which, like, you know, int, sure. And let's just see what that generates. And I just rebased, so this might take a second to compile. So if anyone has any questions in the meantime, let me know. Have any of you been keeping up with the Kotlin 1.4 event? I've been watching some of it, but not all of it. So curious if anything of interest happened that any of you want to talk about. Hey, Abdulila, good to see you. Skycolor asks, in your movie app, you used ambient to store the API. Is that something like ViewModel? No, it's not like ViewModel. ViewModel is still kind of a distinctly Android thing, and has certain, depending on where it's instantiated and what lifecycle owner it has and stuff like that. It has certain lifecycle guarantees that are unique to ViewModel. What ambient is, all it really is you can think of it as a way to declare a value that will be like gettable in a composable context, and it's also, you're able to provide it specifically to a subtree of a compose hierarchy, and kind of use it as like a way to implicitly provide certain values to a tree without explicitly declaring them as parameters. And so, the API is like, it's one thing that could be provided this way. It doesn't have to be. In a large scale application, I think that that's a pretty reasonable thing to use that way. But what you need to be careful about is if you have an ambient that doesn't have a reasonable default value, and the API is like kind of an example of this, then you want to make sure that you provide it always, so that you don't get in situations where it might not be there. And so that's one important thing. But like an API, or like things that you can sort of provide at the top level, are things that are reasonable to do that with. Skycolor says that sounds like state, does it not? No, because so state is something that you can, so ambients internally are implemented with state actually, but basically there's no ability for you to change the value of an ambient that's provided to you. Only your ancestors can change it. And so all you can do is provide new values below you. That makes sense. Andre says, Colin, event topic, function decorators. Yeah, function decorators are interesting. I kind of have a lot of questions. And like in general, there are things that there are things that I think I'd like Kotlin to solve that function decorators make it seem like they're solving, but based on Roman's explanation of how they would work, it wasn't clear to me how they would. Asher asks, can we provide multiple ambients on one line? I'm concerned about my indentation. Yes, it's actually like the only way to provide them, but let me show you. So to do that, we have a providers function, and so you would say ambient 1 provides value, ambient 2 provides other value, and stuff like that. And then in here you call your whatever else inside there. So on the topic of function decorators, like one of the things that I want us to be able to do, so like we were talking about an API the other day, so shared element transitions in Compose. Like let's say we've got a master detail page, and you know, my detail page is rendering an item, and in here, you know, item image, let's just call it image, item dot image. So I'm doing like something like that, and whatever. So rendering some details there, and then here it might be, you know, for item and items. You know, I'm rendering some row of items where I just have, you know, some image and title, right? Yeah, maybe that's in a column, I don't know. But so one of the things that would be nice is if these two images are the same image, but they're, you know, different sizes, different parts of the screen and all that, it would be kind of nice if what we could do is we could say, you know, like basically, so that the API I came up with was we could have like, you know, shared image equals shared element, and here I would say like string, and then this would give me some string, and this is like a URL, right? And then this would basically render our image. And so what we could do is we could replace this like this. And then all of a sudden that would create this like shared animation across these images, across screens and stuff like that. So that would be neat if we could do that. And what we really want to be able to do is, like, you know, like let's just say we've got this, right? Item and so like let's say that this, you know, does that or whatever. What I kind of want is, like, so in the function decorator sense, we would do something like shared element or something like that. And then the question is like, well, what does shared element look like? And what we kind of want to be able to do is say, you know, is to create a higher order function that doesn't care about the parameter types of the function that it's abstracting over. So like, it would be nice if we could just say, like, vararg t, you know, or like, you know, function arg t, and I could say t. And then we could say, okay, well that returns a new t, like of the same type. But then, you know, maybe you want to add on parameters or something like that. So then foo into whatever, like shared element ID. I don't know what it is, but like the point is that you're sort of abstracting over the arguments of a function and you know, providing some new function. And then we could say, you know, if this does all that, right, we could say args t, and then shared element ID string. And then here we can do something with shared element ID. And then later on we call and we spread args into the underlying function. Like this is the type of higher order functions that you're able to create in other languages, but you really can't in Kotlin. Like doing something like this in JavaScript, for instance, is incredibly easy. But you know, or in Haskell, like most functional languages will have some ability for you to do this. That's C++ template style magic. I mean, it's really not. Like, I mean, you can do a whole lot with templates, but the point is that, like, I mean, that's like saying type arguments are like C++ template style magic. Like, yeah, you can do that with templates, but just because it looks the same doesn't mean that it is a template, you know, type thing. Like, this is what this is a more powerful type system than Kotlin has. And yeah. Like doing this in TypeScript is also super easy, but not here. Anyway, that's enough of that. Vicus asks, can Lazyrow 4 have an item as big as size or parent width? Like recycler with full width child items. Maybe a basic question. I tried it, next item also showing. I see what you're saying. You're saying that you want the size of each child to be like the full width of the screen, so that it's basically one item per screen at a time. Yeah, I think that you can do that, but I forget how. I think maybe there's a special modifier in the scope of the lazy column. I don't remember, but I do remember some people having this conversation. So I know that we've discussed it. But I don't know off the top of my head, I'm sorry. Andre says, I would imagine JVM wouldn't like this function arg parameter so much, so it would have a lot of arrays and boxing involved. I mean, the thing is that the JVM already has function n. I mean, and all parameters of function types are lost anyway with type erasure. So like they're all just getting passed as objects, and you know, the ability to pass an array of objects is easily representable in JVM. And so I don't actually see any issues implementing this with JVM, but maybe I haven't thought about it enough. But to me, this is purely a type system thing, and every single type represented here seems representable in JVM. So I don't know, but I could be wrong. I'm not a language designer, and I've only thought about this a little bit, not enough. So, okay. So we're back here, and this is the bytecode that gets produced, or the signature of that bytecode, which makes a lot of sense. Now what I'm curious about is if I say let's try this. Let's just do like a simple recursive call, and I will call example with 1, 2, 3. So let's just say it +1. Or actually, what I can do is I'll just do that. I mean, this doesn't have to like make any sense, but what I want to see is, one, I want to see what happens to this lambda literal that is going to get converted into an A. So I want to see how that ends up, and then I want to see, you know, probably not important, but I just want to see how this gets passed around and things like that. So I'll go ahead and run that. Skycolor asks Alpha 5 soonish. As far as I'm aware, Alpha 5 got announced this morning. I think it should be available now. Unless I'm missing unless I missed some issue. I'm not sure. Let's see. What does this say? Unresolved reference. None of the following candidates is applicable because of receiver type mismatch. Oh, deep. Yeah, I think we released it a few hours ago. 9:33. Okay, so I just wonder at first, like, what happens if I just do this. It looks like something, it doesn't like something about the recursive nature here, deep recursive function, but I mean, obviously this code would just, you know, infinite loop, but we're not executing it, so I didn't think that it would, I didn't think that it would matter. Maybe you have some prelude included. I do. I mean, I do. I think that's why it's line 9, but it shouldn't be affecting anything. I'm just pulling in the runtime. Oh, I see. It didn't like that. I have to call a dot do something. Got it. Thank you. Okay. Let me just fix that real quick. So this will be you know, let's just call this that. A dot compute. Oops. All right, I'll do that and see what it produces. Yeah, thanks Nikita. I missed that. Okay. All right, so this is what that produces. And this is really nice. I like this a lot. So, I mean, we basically have exactly what we'd expect. We've got this example function, which just accepts an A. And then we've got this other synthetic class, which was created from this, which implements A. And it's got a capture scope of A. It's got the compute method. And it's an inner class, basically, which is what that's saying. And this is the outer class. Okay, so very clean, very nice. We can just like give it a shot here and see what happens if we add composable here. And so I don't actually need to make example composable because the only composable invocation that's happening here is here basically. So, and that method is composable. So this all works. So let's see what happens. Sorry, catching up on some questions here. So Vikas asks, will there be any guides on Android website for Compose, which we have right now, for other native elements? We have one page, but with basic example. So Vegas, I'm not sure if you found the Compose pathway, but there's like quite a bit of Compose documentation and like code labs and all kinds of stuff. This might be useful for you. Let me paste it in this stream. But this is what I'm talking about here. This has some tutorials, videos, articles talking about the mental model, has code labs. Again, more videos and code labs and just like a lot of stuff here, which maybe you've seen that, I'm not sure, but we're definitely going to be putting more and more out as time goes on, but I feel like there's definitely a non-zero amount right now, so take a look at that. Okay, so let's see. So we got an error, which composable invocations can only happen from the context of a composable function. Okay. So that might be the first thing that we want to fix. Like, all of this should be okay, because we're not invoking a composable method anywhere except for already like in a composable function. So I'm gonna fix that first. So to do that, we've got a call checker, and so this is where the calls or where the diagnostics get reported for this. So to start, I'll just set a breakpoint point wherever we're reporting this and just debug. Is this just me, or are other people having issues with recent Canary version of Android Studio? Lots of unresolved references and classes not resolving properly. Sean, so which version of Android Studio is it? Was it Canary 13 or 12? And what do you mean? So there were a lot of issues with that release. A handful of them were pretty painful. Might be what you're running into. Okay, so yeah, 4.213. So the issues that I'm aware of, so let me know if you're having issues separate of this, but so one issue that's happening is when you command click into, like, say a declaration from another jar, like an external declaration, the sources aren't being mapped properly. So you end up with like decompiled class files instead of like the actual source code. So that's a known issue and is being resolved. Another issue that I was aware of was sometimes when you would hit like build and run, you would get an outdated version of that built artifact on your device or emulator, and then you'd have to like basically hit it twice in order for it to show up. And that was related to the preview. Basically, I think it's related to like the build on save feature of the composed preview. And so try checking that off if that's an issue that you're running into. Let me know if what you're talking about is not one of those two things, because it sounds like you have maybe a separate issue with like unresolved references and stuff. Yeah, I haven't seen that in particular. You might want to try posting a bug, and you know, see if there's anything, if it's been reported before. I don't know. Julius asks, is there some workaround for the sources bug in Android Studio? So I'm not sure. Like, I think you can still add the sources manually, but I think the problem was that like the way that artifacts are stored on Gmaven is like not working properly, or like Android Studio, like the way it looks up those sources is wrong or something. I don't know. It seems to affect all of Gmaven. And I think if you download the sources jar directly off of Maven, or if you just have the sources locally, then you could tell Android Studio to look there. But that's not really like an easy workaround. So sorry. Okay, so let's see what's going on here. In which version of Android Studio will Compose work in stable channel, not canary? Kind of tired of canary lags. Yeah, this, I don't have a great answer. Basically, I think the real answer is, I think once Android Studio starts getting built with Kotlin 1.4, but I'm not sure when that will happen. Sorry, I'm not a part of that effort, so I just don't have a lot of information. Sorry. Okay, so let's see what's happening here. So we get a resolved call, and that call is the compute call. All right, and we walk up and we end up here, KT lambda expression. And we get a descriptor. So this is kind of, it gives us an anonymous function descriptor, but this is, so I think ideally we should have some ability to connect this function descriptor to A, but I'm not sure what the right way to do that is. So we're gonna have to figure that out. Julius asks, what are the advantages of the ordinary lambda types over function interfaces now? Is it now preferable to use function interfaces where possible? I don't think so. I mean, I think that I think that lambdas are, oh man, my voice is going crazy. I think that function interfaces are useful at times, but definitely like the number of lambdas that, you know, I think just lambdas are just way lighter weight and like easier most of the time. And so that's kind of how, like, I don't know. I think you could probably come up with like a decision-based framework around which one to use, but I haven't thought about this in enough detail. But I think that there are some maybe important distinctions between the two. Like if you have so one thing is like when you have a function interface, you know, this is like the, you know, main method kind of thing. And one of the things that you can do is you can have like a secondary method which has some default implementation. And what's nice is that this can still be a function interface because it's only one like required to override method. And so this can be nice if you want to give the like the consumers of your API a way to define like some extra behavior, but where like the default behavior is kind of the common case, and so they won't often need to do that. And so most of the time, them representing it as like just a simple lambda might be preferable. But the other thing is that like you have to like name this thing, and you have to like, you know, think about it as like a first-class citizen. Whereas, you know, a lambda, it's just nice sometimes to just be able to say, you know, okay, this is I'm gonna call this whenever I call this. I don't need it. I don't need to name a type for it or like, you know, anything like that. Like it's just a much more, you know, ergonomic and simple, and doesn't have the same cognitive overhead that like a whole new type for this might carry with it. And so honestly, I would lean towards continuing to use just normal function types, unless there's a good reason why you need a function interface. That would be my recommendation right now. Yeah, so the whole get value import issue is that actually has nothing to do with Canary or not. That's just a problem in the Kotlin plugin. It is painful. I agree. We should fix it, or someone should fix it. But it's more a result of like how we've structured our API, and we need the get value implementation of state to be an inline extension function, or else there's a bunch of optimizations that there's a specific optimization that we would miss out on that we really don't want to. So that's kind of, I don't know, what's going on there, I guess. But yeah, sorry about that. So I wonder here if like there's some so basically the challenge right now is that we need to find out how to map this local anonymous function, this function descriptor. How do we know that it's part of a function interface? That I do not know. So one of the things that I might just look for is, so Kotlin defines all of these like binding context things, and I imagine they might have added some new ones to support function interfaces, and I want to see if I can find any of those that might make sense to use. not seeing much here. New inference. Okay, so I don't think that that'll work, but so we've got this lambda expression, and then I think that at some point we grab whether or not it's an argument to something. So here we go. So we've got, do we have an arg present? So we do have an arg. Okay. So I guess what we want to do is figure out if this argument is a function interface. So it's inline utils. So I guess we can look at the type. So Sky Color says this is a total noob question, but is the following a valid syntax in Kotlin? Suspend fun inline class A. So no. So right now you can have an inline function, but like so an inline class, it would need a constructor parameter. And so then there's not like a function inline class or anything. So prepending inline class with suspend and fun, those are two like qualifiers on class that aren't applicable. If you got rid of class, then you can have, I believe, inline suspend functions. So you could have like, suspend inline fun. I think that that's valid, but not sure if you had more to that question or not. But yeah, okay. So I want to figure out here, like, let me just stop this. So at this point we have an arg. Type. Like I kind of just want to know like if there's some is function interface or something that like I don't know about here. So So I guess we can get the descriptor of the type, and then is functional class. I want to do like it as class descriptor because I think that's a classifier descriptor. So, and then I guess this is, I get is fun here. Kind of curious where this is used. Ah, so there's a function class descriptor. That's interesting. All right, well, let's see if this is maybe enough here. So I think I kind of want something like this, where we could say so we have a value parameter descriptor. And then, maybe we could just ask like, is convertible to function class? Or what we might want to do is, so here we say function class descriptor. So maybe what I really want is is function class. Function class descriptor or null, maybe. Let's just try that. And then I can use that up here. So if arg is not null and arg.type dot function class descriptor are null. Actually, let me do this. Val fun class. And I'll say if fun class is not null, so if it's a function class, then what I want to do, so this is a lambda argument for a function class type, which means it's going to get converted. So then I'll say main method equals class dot Oh, you know what? This is probably not what I am looking for. Is fun. Artur, it's a font called Dank Mono. So, I mean, it's kind of weird. Like, I don't actually know. I mean, so there's like this is fun property, right? Which, like where's the is fun property here? Yeah. So I kind of want to figure out where this is returning true. Well, it's weird that this isn't. It's like not showing up in here. Thanks for coming, Power G. All right, let's just try to implement this. I think this should just be a class descriptor. I mean, is there like it's not like an interface descriptor or something like that. Is there? Oh, well, that's interesting. There's a function interface adapter descriptor. But I don't know where to find that. Okay. Like, where is that? Okay. Function interface. This is weird. Okay. All right, I'm just gonna debug again because I need to find out more about this type. You know, I wonder if there's information in the resolved call. Because in order for that call to have passed type checking, it needed to know. Yeah, that's probably where I should look. That's interesting. Because I get... Where does this happen again? So I get this resolved call. Oh, interesting. You know what? I shouldn't even be going down this path because this should be returning false. Oh. This is the wrong... I see. Okay. Yeah, so no, it is actually a composable invocation, but I need to realize that I'm in a composable context. Ugh. Which that's why I'm doing that. Okay. All right, so in here, got the argument. And so all I really have is the type. So I can say arg.type. Type. So I think I want to okay, I mean there's this SAM type. No, I don't want that. All right, what I'm gonna do is I'm gonna get the constructor and so this is the A class, which, so it has is fun true. It's a lazy class descriptor. Okay. So, I mean, at the very least, I can just say if dot is fun for that. I wonder if this gives me any nice functions here. So declaration descriptor. So this is just a classifier descriptor. I wonder if I at least cast it to a class descriptor. Here maybe there's like default function type for SAM interface. I kind of want to see what that says. Okay, it does say something. So this is interesting because it says, okay, default function type for SAM interface. And it gives me that type, but it doesn't give me the @composable annotation, which is kind of what we want. But it's fine that it doesn't have it. Like I wouldn't expect it to. But I might like trace down that logic to see where that's coming from, like what they do to grab that. I'm just gonna copy all this, put it in here. Val arg type descriptor equals so there's the descriptor, and then I'll say if that is not null, I want to find out where this is coming from. Oh, interesting. This is only a fallback. Okay, get function type for SAM. Let's see if we can open up this file. Okay. What? Oh, interesting. Okay. Same type itself. Each projection. I'm not sure this is doing the same thing for us. What do we get here? As type projection. Okay. It's weird that this says to use this where it doesn't seem. All right. Get SAM conversion resolver. Okay, I want to see where this. So that just returns null. Okay. The way this works is kind of surprising to me. It's a little more convoluted than I thought it would be. So there's Java-based SAM conversion. Which is not what we want. All right, here's the implementation. All right, this is probably what we want. Get abstract member. All right, let's see if this works for us. This kind of seems right. Single abstract method or null. That returns a function descriptor. Okay. So we've got a class descriptor. And then what we want is val sam equals and then basically if we have a single abstract member and this has a composable annotation, and then we're good. I think I can just return at that point. So let's set some breakpoints here and then see if we get down here. Okay, so here we are, and in this case, Sam returned us the composable method, so this should return true, and then we should be good. So it looks like that worked. Now I'm gonna hit continue, but there's a good chance that this test still fails, because all this did is prevent the diagnostic from being there, but we're still probably not generating the right code at all. So let's see what happens. Okay, so it did go all the way through code generation, which surprises me a little bit, but let's see. Let's see if this makes sense. So now our function interface has a compute method, which takes an int, a composer, and an int. So that looks correct. And then our implementation of A also does that. So interesting. I mean, it might have worked, really. I'm curious if I dump the full bytecode here, what this bytecode actually looks like. All right, so now we've got the full bytecode output. I'm just gonna put that in VS Code. Take a look at it there. So what I want to find is, let's look for this compute method. Okay, so this is, what class is this in? So this is in our implementation class. Let's see. It looks a little light. Oh no, this invoke virtual example 1. So Sean asked, next dog fooding stream was Sunday, right? Yeah, we'll be doing more dog fooding on Sunday. I might be starting a new project though. If you have any, I don't know, if you have any ideas on some interesting things that I could do, let me know. I'll be trying to come up with something between now and then. Okay, so yeah, so this doesn't look quite right. We've got got this class. So I'm a little bit confused because we've so that's where we do the +1. So this bridge method, all it's doing is calling the non-bridge method. And I'm not sure why that's needed for function interfaces, but anyway, so it's only passing on the ints, so that's like wrong. And this is like the actual body, and all we're doing is this. And so really what we want is we want the composer to show up here, and then we want to be generating some code here, like start group and end group and stuff like that. Hey Danny, yeah, we're looking at the bytecode produced from this. Basically, we're trying to get function interfaces working. So I have this example here. And I'm just going to make this 1, 2, 3 so that it's easier to find in the bytecode. I'll just do 4, 5, 6. But okay, so the next thing I think is to figure out what the function body transformer is doing. So we'll keep this test, and let's see. I think it's all to the right. Let's do param transformer. I think this is the first thing we'll want to deal with. Param transformer. And then let's also look at the function body transformer. Artur asks, how should I explain to my girlfriend that I'm taking a vacation only to review all the stream recordings of a guy from Google? I don't know. I mean, what do you think she'll say? I'm flattered, by the way, that you'll that you'll actually watch all these recordings and are finding them valuable. Appreciate that. Or I'm glad to hear that, at least. Okay, so visit function. So I think we let's set a breakpoint here. I mean, I'm curious, because I'm curious what we choose to do here. All right, let's debug. Because actually it's like we'll be visiting a function, I guess, but it's like it's a lambda, so look at what do we have in here again? So we visit a function. Is that the only thing? No. We also, we must like visit call or something too, right? I guess this must get called with the lambdas. Okay. So what declaration is this? This is abstract fun compute. And where are we? We're in... So we're in the interface right now. So there's no body to this function. So I assume we're going to do the right thing here. This is just like any other interface with a composable method. So now, where are we? Okay, this is equals. Don't care about that. Hash code. String. Okay, so this is the example function, which takes in a. And so this isn't a composable function, so we don't care about it necessarily. Okay, so here's the lambda. This is the one that we care about, and I suspect that we're transforming incorrectly. So what build system is used to compile Jetpack Compose source code? It's not Gradle, right? No, it's Gradle. We use Gradle for Jetpack. It's a very complicated Gradle setup that I don't understand at all, but it is Gradle. Okay. So this logic we're gonna need to change. So we use the descriptor here, which is not great, but this is probably wrong. But so theoretically this should be correct. So we may need to set this somewhere. Yeah, okay. So we're not doing this yet, but we need to be. At least I think so. Let's validate that. Okay. Yeah, so this wasn't set. And this isn't going to be set. Although potentially this could be. So let's continue onto there. Nope. Okay. So I'm gonna find out where we set this because I forget. Oh. I see. So that's third composable. Okay. So here's where we set it, and we might need to do more here. All right. So let's figure that out. So basically what's happening is we have this type resolution interceptor extension, which the idea is that there are lambdas in some places where, you know, it's just a lambda literal, but it's getting inferred by the type system to be composable. And so one common place this happens is when you pass in a lambda into a function and the argument type is a composable function type. Well, function interfaces is a new situation where this happens. And so in this case, the fact that it's composable is inferred. And so we need to mark it as like inferred because the type system's not going to do that for us. And so this is where we do that. Okay, so I'm gonna uncheck all of these. Okay. So this is basically where it is, I think. Okay, but this might not work because so we need to find that. I'm going to go back to this page because this is where we just added the code that sort of determined what it was. So if we have a function literal, we want it, so we have a lambda expression, right? Function literal. Okay, get argument descriptor. Yeah. So what do we have in the type interceptor? We've got a lambda here, and what is the element? This is a lambda as well. All right, so one thing we could do is we could say element arg equals, so this gets us our argument. I wonder when this happens versus when this happens. It seems like here might be the better place almost. Okay. Oh, because this isn't function literal descriptor. Well, we'll see. Let's see if we can do it here. What is this? Make it public. Where's that? Oh. All right, let's try and well, I'll just make this internal. I don't think there's any reason for it not to be. So then up here we do this. which that we might want to turn into, maybe this should be a helper function. Okay. Let's see. So if we've got all that and the abstract method as a composable, then this is what we want to do. Okay. I think that that might be enough. I'm not sure, do we even use this anymore? So where is this? Use it here and here. Record. Okay, well, maybe we should try and set both. I'm not really sure. I'm not sure when this one gets used versus this one, or like why one would get set and not the other. Anyway, let's verify that this gets called. Archer says, Roman at JetBrains said that in cases like composable, some annotations should rather be a real keyword like suspend, since it's kind of different kind of function. Do you think of this? Yeah, definitely. So, I mean, this is adding a soft keyword like composable would, I mean, it'd be great. Like I want composable to feel like a language feature more than an annotation. And I think long term that maybe this is an option. Like we've talked to JetBrains about that loosely, but you know the problem is that, so one, adding a keyword like that is like a I mean, it's a big change for a language. So you need to update the parser, and it's like, you know, it's kind of a real deal then. And so at that point, then the language needs to know what the meaning of that keyword is, and the composable its meaning is really baked into our compiler plugin, and so the compiler plugin would need to become part of Kotlin, and I don't think we're ready for that yet. I think that, like, hopefully we will be someday, but I think that we should take our time with this. And that in the meantime, an annotation serves, you know, all of the same purposes without requiring us to bake it into the compiler proper. And that's kind of nice. And actually, I mean, so I like the keyword. Like I want us to have a keyword eventually. Not sure if that'll happen, but that's what I want. But like we saw, I mean, so there's a very old conversation from Andrei Breslov in a keep somewhere where he kind of indicates that at one point they were considering pushing Kotlin towards no soft keywords like this for functions. And so like suspend and inline and stuff like that would actually just be annotations, even though they were like proper language keywords. Just like how, you know, in Java you have the @ symbol for like @ overrides, and that's like a language feature, but it like kind of looks like an annotation. And Kotlin could go the same way. I think they probably aren't going to anymore, but I know at one point Andrei Breslov was considering moving away from keywords like suspend and inline entirely, and just having them be annotations. But I'm not sure if they're not or what, but I like the keywords more personally, but that's just me. Okay, so we've got the param transformer. Interesting. Is this a new? Yeah, okay. This is a new bug. So now it shows up, it's a mismatch type. So this is like kind of a bug on me, I think, but these error messages are kind of annoying because basically, you know, inferred type is this, but this was expected, where they're the same thing because it's neglecting to print the @composable as part of the annotation, or as part of the like type signature. And so we need to generate like a better type in that case, but not entirely sure why this happened. So I mean, because usually it's only us that issues this diagnostic. So so we report this in some cases. Maybe this is why this needs to be specified. So let me do like the same thing up here. And then we'll probably refactor this so that we can deduplicate some of this logic in places. So in this case, we then have expression. And let's do this. Inferred composable descriptor. Okay. Yeah, let's give that a shot. So I think it was us that, like, I think we kind of failed there because we recorded that type mismatch error. And this is probably the problem. Like I think this is, yeah, I don't know. Let's find out. Abdulila, what do you mean? What are you classifying as an undocumented feature? Okay, so we expect to be here. This is fine. Go ahead and remove that breakpoint. I want to see if we end up here, just to see if that gets hit. Okay. So what do we got here? We've got expected type is function 1. And then the expression type is at composable. So where does the expected type come from? Okay. Check type. So I think this seems weird. And then, so is composables true? Expected composables false. I guess what I want to find out is like, let's see. Like, did I need to update the expected type somewhere? I guess I want to start over and find out if this got called or not. Yeah, like I wonder if we should use that inferred thing here or not. Feels weird. Okay, so this is getting called. All right. I'm just gonna ignore this for the moment. Okay. So this is now getting called. And so is composable is true. But I see I remove, so both of these have gotten called, I'm guessing. But the expected type is not what we expect, which is a bummer. Because the whole point of this method is to take an expected type, a result type here, and instead of like basically changing it to be the composable version of that type. So from both the descriptor and the element, we should be able to figure out that this is inferred properly. I think that it kind of, that sort of goes against what this whole thing is doing. Like at this point, the expected type should be that. So, I mean, what I might do is just say, if expected composable or so in this case, we've got function literal where the expected type is composable, but it doesn't appear to be yet. If we binding context compose writable slices dot. So if we get the inferred descriptor, so basically now we're saying if it was inferred as composable, then just bail? That really, I don't know, this doesn't feel right, but I'm gonna do it and just see where it gets us. But I don't like it. Computer's really struggling right now. 98% CPU. Delilah asks, what CPU am I using? So I'm using a 15-inch MacBook Pro. Not sure what CPU that ends up being, but I can find out. Okay, so we reached there, which is expected. So my processor is 2.4 gigahertz, 8-core Intel i9. Apparently. Okay, so now we're back in the param transformer, which is good. Now this is compute. We're inside of A, so I don't care about this one as much. I care about the lambda. Okay, this is equals hash code, string. This is example. And then this is the lambda. So this is what we care about. And so this, so is composable callable should return true, which means we should hop over this, which is great. And this function is an inline lambda passing the argument inline. Okay, I think this is fine. I forget about that to do. Okay. All right, so this means that we copy it. Which is good. So let's go ahead and continue. And this is compute again. Oh, this is for a call. Okay, that's fine. All right, so I think we can pass there. I suspect that that all happened correctly. And then here, So this is the abstract compute, which won't have a body. Right. Yeah, body, so I think basically that'll not go through there. Declaration dot body is null. Okay, so that'll go past that. This equals hash code to string example. Okay, so then this is the lambda, which this is the interesting part. So one thing I wonder is if scope dot is composable is true. Oh, well, I don't have the function scope yet. Okay. So now scope. All right, so it is marked as composable, so that's good. Let's just keep seeing where this is going. So it should be restartable as false, which seems correct. Is lambda. So is lambda ends up as true, which it is like an anonymous lambda thing, but we actually probably should treat it differently. So we'll have to think about how we determine that, but this is probably kind of wrong. Shoot. Okay, well, it's 3:30 now, and I actually have a meeting I need to get to, so I'm gonna have to cut this stream short. But I'll probably, I mean, well, I guess we won't pick this back up until next week, but I'll probably be finished on it by then. I'm not sure, but maybe I'll just like stream it off schedule since we already started it. But thanks everyone for joining in, and I hope this was entertaining to watch. And I will see you all on Friday. Cheers.